All right. Okay. So, welcome everyone to today's info session. It's great to be here. It's great to have everyone here. And we're pleased to have you here for this session on low-cost computing in manufacturing. I'll just give a little bit of introduction. My name is Chukwuemeka Fibo. I'm with the Africa Deep Tech community. And if you're here, it's probably because you heard about the Africa Deep Tech Challenge. The Africa Deep Tech Challenge is an innovation challenge put together by the Africa Deep Tech community and the Africa Deep Tech Foundation. And we are doing it in collaboration with our partners, Future Africa, IHS Towers, and the Ilorin Innovation Hub, right? So the whole idea of this challenge is to find the best and the brightest in the region who are building things with the theme of resource-constrained computing. And I'm going to put a link to the challenge here so that you can get more information if this is the first time you're hearing about it. But basically, we're looking for people who are doing amazing and crazy things in the area of resource-constrained computing. And if you submit something and the judges like it, you stand a chance of winning up to $8,000 as a first prize, free grant, or second prize of $5,000, or third prize of $3,000, or you could even get one of our special category prizes in the area of power management, sponsored by IHS Towers to the tune of $4,000, right? Or if you make it to the semifinals, or the finals, you stand to get mentoring and even connection to potential investors and all that good stuff. And of course, we're going to promote you from here to the moon if your solution is up to scratch, right? So it's an amazing challenge, and we're really excited to see what you'll all build. As part of this challenge, we promised you that we're going to be bringing you some of the top people in the industry who are doing amazing things to share with you and inspire you on certain areas you could build in, right? And today, the theme is low-cost computing in manufacturing, right? Which is one very awesome application of resource-constrained computing. And we're very, very delighted to have with us Maxwell Maduka, who is the chief engineer of Terra Industries. You may have heard of Terra Industries. They are one of the, I'll say, hottest things right now when it comes to manufacturing in the region. And I don't want to take the thunder away from Maxwell. I'll let him talk more about himself and about, Terra Industries and what they do before he goes into his talk, but I'll just pop their link here in the chat as well. So Maxwell, if you're there, you can hear us, please come on screen and take control.
Hello everyone, my name is Maxwell Maduka. I'm the CTO and co-founder of Terra Haptics. Basically, now called Terra Industries. We had an evolution from Terra Haptics to Terra Industries very recently, and you can feel free to ask me why we changed the name later on, but that's by the way. So yeah, this has been a long time coming because we plan to do this class. I'll call it a class, not just me just speaking a bunch of like stuff that I planned out on this slide. Is going to be actually an actual class because the reason why is we need people who have been in the industry already, that know what it takes. That is, you might not necessarily understand everything that it takes because this is, I will call the hardware industry or the deep tech industry, manufacturing space, an unfolding space. It's been a space that has been so niche, especially down to high-tech manufacturing, that it is a space that is unfolding. It is a space that new players are coming in, understanding what it takes, understanding what this market needs, and especially trying to know that, okay, we're not just manufacturing for this market, which is Africa. There's the emerging markets, that is LATAM, that is beyond even Africa, the emerging markets, and then also going global, because the one advantage we have is we can produce things that are good enough and that are cheaper than what most markets will offer their players. The military market is large. At Terra Haptics, people normally say that, okay, yeah, why don't you just do defense? Yeah, the military market, it's great, bulk money, but we miss a lot of times, especially as builders, that Africa is not a market that is random like America, where somebody can start a swimming pool company and be making millions of dollars every year. So we are in a market that is facing several crises. And I know that it's weird starting my own this thing off like this, but we're in a market that is facing several crises, three major crises amongst many that we can play in. And this is for you all that are saying, okay, what can I build? What market can I play in? What can I make better? What problems can I solve? We have three major problems. We have a security crisis. We have an energy crisis, and we have a security crisis, energy crisis, and we have a food crisis. Yeah, starting from the last one I mentioned, we have to find a way to optimize food production, scaling up food production, and not just the food, also the things that help us grow the food, from the fertilizers to the chemicals that help with food production, to moving into soilless, farming, being able to automate irrigation at scale. By the way, always remember that you have to think about doing things at scale, not just for the first 100 people, not just for the first 1,000 people, but for the first 100, the next 100,000 people, the next million, because it's not 5 people that can bring $1 million each. It's about 100,000 people that can bring 10,000 naira to $10,000 each. I'm using dollars instead of naira, but just convert that dollars to naira basically, or replace that dollars with naira. Yeah, but that's the kind of market we're playing in. That's the kind of market that, the more we grow in manufacturing capacity, that's what it's going to be. So let's get down to my seminar. So yeah, we're going to be talking about low-cost computing in manufacturing. And the question is going to be, why the urgency? Why do we need to have that adoption now of all times? We are a very digital market, where our greatest strength, especially as tech people, have been exporting our own talent. We don't produce. We don't produce anything that we export. We just basically just learn with resources provided by foreigners and then export that talent outside, otherwise known as Japa theory. And we're like, okay, is there something we can do here that can make us just as much, bring revenue, not just to us, but for the country, and then we can also export to other clients that it can be used. And we're like, yeah, there's China exists, America exists, Russia exists, you understand? But there has to be something we can do, right? And we have to understand that for us to be able to drive that adoption, the adoption of our technology somewhere else, we need to adopt it for ourselves. So manufacturing is undergoing a revolution driven by necessity across the globe, in the world. And, even in Terra Haptics, we've realized that, okay, for every single time we climb a new revenue, scale, a new revenue like target, there is need to scale up automation. There's need to scale up, production capacity. And every single time we try to look, okay, how does Andrew do it? How do people like Andrew do it? How do people like Scale AI do it? How do people like Shield AI do it? How do people like Lockheed, Aerovironment, how do they scale up their own? I'm like, okay, yeah, but realistically, they use millions of dollars. A $10 million factory is a small factory in America. So they're using like tens or hundred millions of dollars to set up factories. We can't do that. As a matter of fact, we shouldn't do that, because of why? So if we can be able to find a way to, okay, can we use low-cost computing, like compute power that would enable automation at the lowest cost possible, still help us to streamline our manufacturing process without any compromise. or in this case, with the littlest compromise possible. So that's what we're looking at. Global disruptions have exposed the fragility of traditional supply chains. Rising inflation and cost of components have made conventional industrial computing platforms also sustainable for small and mid-sized manufacturing. So, like, okay, there's rising inflation cost everywhere. There's cost of components can be a serious problem. You could say, okay, I want to make things cheaper, but the parts for the thing you want to make cheaper may not be as cheap as you expected. So you have to find a way. You have to find a way to vertically integrate at very low cost so that you can be able to even compete. Because we like to make it look like, okay, in manufacturing, price is not a problem. Yeah, price is not a problem if you're doing government contracts every single time. But we're going to be serving industries like the industry we serve, critical industries like oil and gas mining. Price may be a problem because yes, they may have a lot of revenues to be able to tank a lot of costs, but we still want to serve them with technology that is, more affordable than what they would find in clients like China, clients like America, clients like the Netherlands, all the other places, Australia and the rest. And here's the thing, open source tools. Yes, I know you wouldn't want to hear that because yeah, at Terra Haptics, we don't do open source, we don't do off the shelf. But not a lot of companies are Terra Haptics, or not a lot of companies are Terra Industry. It's Terra. And not a lot of companies will be solving problems at scale the way Terra would be solving those problems. So you're like, okay, yeah, you will have people on this call right now. You guys can see me, right? And hear me well. I just wanted to make sure that you guys can. If I if I like talk too far and then realize that no one's hearing me the whole time.
Yes, we can.
Okay. So we want a situation whereby there will be situations whereby you're serving farmers that just have like 5 or 6 acres of land and want to automate irrigation. You might be solving that problem for them. You might be solving their problems of helping them find issues with their tractors or helping them find, detecting issues with their current on-ground machinery quicker. It might help automate that process so they don't, their machineries don't reach the point of no repair without them noticing. You might be solving a problem whereby you're helping industrial plants detect anomalies in their production process, detect anomalies in their asset management process way before any human being can be able to detect those problems. And these things will require you introducing certain low-cost computing processes, which would also involve you going open source. Yes, you can definitely integrate your own software solutions into this hardware. But now, what kind of hardware are we talking about here? You don't want to go all crazy on all the whole NVIDIA hype. You're not Meta. You're definitely not OpenAI yet. So you got to look at, okay, how can we solve this problem? Lowest cost possible. Customers can afford it. You understand? Or at least know that they can afford it at some point in time. So talking about open source tools that are accessible, microcontrollers, that are more mature, like the Raspberry Pi. We even have NVIDIA Jetson and like it's stuff like that are also robust and affordable. Africa, in particular, you understand, is poised to leapfrog traditional industrial infrastructure using modular, low-cost systems. That's the goal. That is how we should think when we're solving problems for these critical industries. When we're solving the energy crisis, when we're solving the food crisis, when we're solving the security crisis. At Terra, we think, okay, we have a market. This will work here. This will work anywhere in the world. But most importantly, here we think, okay, how do we bring out traditional surveillance systems? What you find anywhere on the market, but make it more modular, make it low cost, integrate with state-of-the-art software, and ship it out to anybody. Incredible after-sales service, better than anyone would. We're saying, okay, we are giving the industries a huge boost in not just their security, but also their asset management. You understand? And basically, like I said, leapfrogging traditional industrial infrastructure using these systems. At Terra Houses, we believe that the future of high-tech robotics and UAV manufacturing lies in, scalable, locally integrated intelligence systems powered by such tools. You understand? We have the Raspberry Pi, we have the ESP32. ESP32, I will forever be grateful to the creators of that system because they enabled a lot of things that took me from, okay, the regular Arduino Uno. Arduino Uno is still a great great tool, but took me from, the Arduino Uno. I basically went from Arduino Uno, Nano, the Mega, boom, ESP32, Raspberry Pi. You understand? Those are the kind of things that we're going to be working on. And I'm pretty sure that a lot of people working on this challenge. I just, I didn't have an idea of what the cost or what the prizes would be until now. And I'm like, if I knew since I'd have just, signed up to. I've won a lot in the past. Might have just win 8K now. But so I'm going to let you guys win. So yeah, you guys can have this one this time. But for a lot of people who will be joining this thing, let me just give you these are the kind of tools that you'll be looking at. And I'm pretty sure these are the kind of tools that you'll be going for because they're accessible, they are very, very modular, they're scalable. There's a lot of things. Basically, plug and play is not the accurate word, you understand? But pretty much sums it up. And at Terra, we are using these tools. Terra, we basically use more high-end tools, more custom high-end tools. Doesn't mean that is what we started with, by the way. We started with more, open source tools like, Raspberry Pi. That's what we started with before we now scaled up our infrastructure. And that's how we should be. We are entering, or we are in a society that doesn't understand process. We should understand process. I know there's a saying, I don't even know if that thing is in the Bible or if it's just a saying. If you're going to do anything, do it well. I know that saying exists. But I was telling someone who needed advice on startups, on life, on career, and I was telling the person that, look, one name, and Kangwage, meaning, sorry, let me say it in English. Let me tell you. I know the saying goes, for anything worth doing, do it. For anything worth doing, do it well. Let me tell you, for anything worth doing, do it first. Start doing it first. Because if you say, okay, I want to do it well, you might not hit the resources, the manpower, or otherwise talents that it will take you to do it well. But if you do it first, be good, like start first. You understand? With time and with God's help, with the necessary efforts, and with God's help, the ability, the resources to do it well will definitely hit you. That's how my life has been. That's how growing Terra has been. We didn't have the resources to do it well when we started. We had the resources to do it first. Start it first. We knew where we were going. We knew exactly what we wanted. We knew that we were blessed with the spirit of excellence. And then we started out. There was a lot of mixtures. Things got lost, things got broken. You understand? Things got broken beyond repair. But we understood that, okay, we know exactly where we're going. We know the industry we're trying to serve. We're understanding step by step what they want. Then after understanding what they want, we're now understanding step by step how to help them get what they want. Or in this case, what they needed. And that is how we got here. To the point now we are not doing it well. Because we first of all, we started doing it first. So we're using these tools to streamline UAV testing, monitor production line health, automate part of our Q&A pipeline, all while maintaining flexibility and drastically reducing costs. You will be surprised how much we've raised since we started Terra Haptics. Even anytime people come to the factory, even see work, because our factory, we treat our factory like a product where there are versions basically released versions of the factory. There's version 1 for this particular stage of the company, version 2 for this particular stage, version 3. We're currently in version 4, like we're actively building version 4 right now for a new stage that Terra is moving into. And we've been able to reduce costs drastically because of these tools that are at our disposal. And also, one thing I love about us, you understand, builders from this region, is the pressure. The pressure is a lot, but we think inside the box. I don't know how to say. We don't think outside the box because I don't think we're allowed to think outside the box in this region. We don't have the money to think outside the box, but somehow we make thinking inside the box work. And I promise you, you will get the accolades for thinking inside the box, for thinking, okay, what do I have? Look under your couch, look in your wardrobe, look at your office. What do I have right now? And what do I need to solve? What do I have right now that can help me get to that goal? And somehow we do it, gets done. You climb you climb that ladder. The first few steps, you're up. You keep going, you keep going. Our resilience is something that I promise you can't find anywhere else in the world. I mean, yes, we're not the only resilient people, but builders in Africa are resilient. It's something that this is not ordinary. God gave this to us. I'm proof. A lot of people on this call are definitely proof. Mazi Emeka is proof that we are resilient people in this industry. So yeah, that's it. So now, next thing, what is low cost computing? How do I explain this in a way now that okay, yeah, low cost computing manufacturing, it refers to the affordable computing platforms like microcontrollers, Arduino, Nano, all the rest, ESP32, and single board computers like Raspberry Pi to automate, monitor, and analyze industrial processes, as well as also implement it into products too. It includes data collection from sensors, triggering outputs like relays, actuators, real-time dashboards, edge computing with limited AI capabilities. Yeah, the AI capabilities will be limited, but as you scale, it gets better. Always know that as you scale, it gets better. Cloud integration for analytics and alerts. So the core hardware and software components are, the hardware we have Arduino Uno, Mega, simple for, it works for simple IO controls, basically. The ESP32 is dual core, has Wi-Fi, Bluetooth, capabilities for the microcontroller, the Raspberry Pi 4, Raspberry Pi 5, full Linux computer with GPIO integration. So we have the sensors basically. And for the main there is a microcontroller in my car. I don't know why I carry one around. I actually carry a microcontroller everywhere I go. I don't know. It's just like habits. I have a box of sensors in my car just in case I need to test an idea. It's in my car, but it's downstairs. But I would have shown you guys on the call. So a lot of these things I'm talking about. But yeah, for actuators, relay motors, solenoids, basically, these are like the core hardware components. With the software components, I'm pretty sure not a lot of us are familiar with programming languages, but if you're going to be working with these tools, there are a few programming languages you have to be familiar with. We have Python, C++, the Arduino IDE basically runs on a C++, on a form of C++, basically. We have the dashboards like, Red, Grafana, Thingsboard. For storage, we have SQLite, simple stuff, and MySQL, and we have Firebase. So a lot of you here want to go into drones. For me, air robotics, that's my specialization. Being a founder means I'm a generalist, but if you remove it from this founder life now, an aerial roboticist by specialization. Yeah. The software that we use in my industry is called Mission Planner. That is, if you're not using like proprietary software, you use Mission Planner, you use Crew Ground Control to do those setups. Yeah. Okay, I'll talk about that one later on, but let me just finish this class. So a lot of people use those kind of software. There's a ton of others for people that are building things like FPVs. So there's a ton of others like the SpeedyBee app, the app that is for SpeedyBee. I'm trying to remember its name because I barely build FPVs. I only build mostly surveillance and inspection drones like VTOLs and then quadcopters, like large scale quadcopters with like autopilot compatible flight controllers. But yeah, so we have integration tools like Blink. I'm sure you guys know Blink. Blink, yeah. Blink is every beginner's companion. It's accessible on Android. You guys need to do a ton of stuff. That time there's a software I used to design. I'm trying to remember its name. It's been so long. I use a PCB, JLPCB. But that time is Proteus. Yeah, Proteus is the name. When I was still in Yabatech, when I was in school, I was to use the design, you know, boards that time, and it was everything for us. It was cheap. it was basically free, not even cheap. It was free, basically. And when we are done there, we used when we are done in our initial setup, simulated how it would work. We brought it out, tested it. We used Blink, to set up for interface. And yeah, good times, good times. It's but yeah, so basically, I'm moving on to a comprehensive lesson. Low cost computing in manufacturing. Sorry, give me a second. Okay, sorry. Okay, very good. Okay, so key use cases in manufacturing. So we have production automation. Now, I want to make something clear. People normally think that it narrows down because we have this they work mentality or follow the one way they work mentality. You understand? A lot of us do. I did. At some point, I wanted to just do what works. But there's room to do a lot more than what is currently working. A lot of things work, but you mustn't do what is currently working because there's a live, right? I think my internet is sorry, regardless of the high tech we produce, I'm still in Nigeria, so my internet is not the best.
Yeah, we can hear you now.
Yeah, but you guys can hear me, right? Okay,
Yeah, I
okay,
can
thank
hear you.
you. Yeah. So we are always triggered to do what works right now. But a lot of things actually work. So there's going to be 5 things I'll be advising anybody who maybe, if you don't know what to solve in energy, if you don't know what to solve with food production, if you don't know what to solve in security, how about I had this idea? I'm giving the idea out now for free. What about you help? There are people who make money from helping the factories who solve these crises, automate their own processes. I'm slimming down. I'm losing weight. Do you know why I'm losing weight? Because I am so stressed trying to figure out how to automate or take the factory to version 4. What we need to change, what we need to do we need to well? Automating that entire process is kicking my ass. I'm a robotics engineer, not a manufacturing. Yeah, I'm running a manufacturing company, but actually people in the factory who actually handle that manufacturing process. But I learned on the job and I got better at it really, really quick. And now I'm doing it like an actual job. I actually get consulting jobs for actually helping people set up their factories. But what if you could have a career in helping people automate their factories, set up their factories, get it up and running, automating every single thing from logging in people who come into the factory to automating carrying out asset management? Let me break it down for you. We have production automation, relay-based switching, timed automation, using whatever microcontroller or computer that is out there, conveyor belt logic with sensors and microcontrollers. You could actually test that theory. You could actually build a conveyor belt rig and test it and say, okay, for people who package apples, or for people who forgot golden morn, you want to be able to detect when there is a faulty production line. Maybe a golden morn has a tear, has the nylon is open. I've seen situations where my Milo is open. Why? Because those guys don't have advanced production processes put in place. Somebody has to do something about that. If they want to, they have to import that expertise either from India or China or from America, which would be too expensive for them. So they went to India or China. The Indians, they don't really care. The Chinese, they care to an extent, but who would care for them more than us, their own people? So we could help them. We could improve the quality of our food, our cereals, our groceries, just by including these processes in their manufacturing process. And we also including these things in their manufacturing process. We have inventory management, RFID, NFC tag reading for stock trading. For stock, sorry, not stock trading. For stock tracking, integration with cloud-based dashboards. We can easily tell how much is produced. We can reduce thefts. We can manage logistics, movement of these goods in and out of the factory, all from the software and the hardware that you're developing. And the funny thing is that you don't even need a factory for this. A small workshop will do because you're getting all of that work done in the customer's factory. We have machine health monitoring, letting them know when their conveyor, okay, they're the one who built conveyor belt anyway. So yeah, letting them know when their steam machine isn't working. For those who produce cashew nuts, what helps separate the separation, the machines used for separation. The machines, people that do peanuts and all these peanuts who produce it, people that do processed rice, letting them know when there's a fault, when they are cement factory, when there's a fault in their machines, quality control logging, predictive maintenance and log alert, vibration sound, temperature sensors, barcode, QR code scanning, operator interface, and HMI, local HMI systems using Pi, touchscreen displays, interfaces for shift logging and fault reporting. These are the kind of things we can actually get done. And this is for people who are still finding it hard getting into the hardware space. The hardware space is beyond building robotic leg and humanoids. No, leave that thing first. You understand? The people who building humanoids, they are far off, I promise you. It's going to take a while before we get humanoids into the manufacturing space. It's going to be a good thing, but right now, there is so much work we have to do automating these processes. Before start introducing robots, right now, we have to make the factory itself a robot. Yeah, that's what I'm doing. Making my own factory a robot and then proceeding to bringing robots into the factory. That's what I'm going to do. The factory should be a living entity whose goal is to produce world-class systems that are going to the customers. Every single nook, cranny, conveyor belt, cutting machine, drilling machine, CNC, lathe machine, every single machine works in sweet harmony to make sure the final production line is spick and span. Or the final product is spick and span. There are people, we need people to go into this line to help us get that done. I'll hire you. I promise I will. Not even a promise. I need to because it's necessary. Yeah. So benefits versus traditional systems, clearly the benefits are high. You understand? There's the learning curve. Obviously, doing it manually it looks simple, but it's going to be way more expensive in the long run. That's just it. So yeah. So we have the actually I didn't even write anything down. I just wrote a list of things I'm going to be talking about. So I'm raw dogging this. So yeah. So the learning part, how to get started learning. So we have the beginner, the intermediate, the advanced, and the professional. That's it. And you know, I'm talking to 21. Is it 21? Let me see how many people are on this call. I'm talking to 18 right now. 18 very talented people. So I'm pretty sure if there's anybody that can actually jump the gun, you can. Do well, but you can. So we have situations whereby you want to learn the basic electronics, which I'm sure anybody that's part of these challenges understands the basic electronics. You've mastered Arduinos, mastered the temperature sensors, intermediate stuff, you've learned Python, the Node-RED, building Raspberry Pi dashboards for monitoring. Go to the advanced stuff, understanding databases, you understand how to store that information and retrieve the information, and also reuse that data to be able to scale up operations as well. And then, we have the professional stuff when you're moving now to high-end graphics cards, integrating, basically working with companies now who even build chips like Terra will soon be working with. So yeah, and you want to start working with sample project. You understand? Let's say, okay, I think let me give somebody here another what you could do for this particular challenge. What if you work on something that can be able to monitor your battery? So a lot of companies have like large scale, like server rooms, inverter rooms. What if you can build something that can be able to monitor the health of the inverters have that, but it's very, very low scale, very, very low info, low data. What if you can be able to, build something if systems are hitting critical limits? Understand the life cycle and the lifespan of every single company's data room. You understand? So what is the future outlook? The future of manufacturing is decentralized, is intelligent, is data-driven, and low-cost computing enables real-time control, visibility, and AI at the edge. Africa's manufacturing sector, it's rapidly, it's growing. It's steady, but it's growing. And if we can rapidly industrialize by skipping legacy systems entirely, you understand? We've been there, we've done that. We don't need to go through. And the good thing about coming in last, let me use the word, coming in last or coming in late, is you don't need to go through the trial and errors that more advanced societies went through to get to where they are. You can skip the whole thing. I know you say, you can't skip the process. All of them who are you can. You actually can. We know the end goal now. We know how they got there. We can skip it and get to the good part immediately with even lower costs. So yes, we can. We already are. So yeah, Terra is, building these future engineering tools that scale affordable. And yeah, we have a training program ongoing right now. So this is nepotism kicking in. Anyone here who is interested in joining our training program should just reach out. And we'll be mild with the selection process. I'm always mild with my selection process. But yeah, we'll put you through a selection process. So you don't have to go through the whole application process. You can just come straight to the selection process. You understand? The fact that you're here means you're serious about what you're doing. So I don't need any selection. I don't need any form to know whether you're serious or not. So yeah, you can just come straight for the selection process. If you're in Abuja, you can just come straight down and yeah, we can talk. So from the Telegram group, you can get my email, or yeah, you can get my email for now. Then we can proceed to more, end-to-end encrypted chats later. But yeah, for my final thoughts, low-cost computing is not just a workaround. It's basically a revolution. At Terra, we are proud to lead transformation in Africa by basically initially embracing low-cost computing practices like microcontrollers, edge computing, and basically DIY innovation before we got to the process we were streamlining and scaling up our operations. I think now it's time to start, and I think we have the right people doing this. We can get more people also doing this, not just building, but also helping the builders build better. Thank you.
All right. Thanks so much, Maxwell. Thank you so much for that great talk. And again, just to remind folks that if you have any questions for Maxwell while he's here, please put them in the Q&A section, or even you can use the chat as well. But I also have some questions of my own to kind of for Maxwell if you're still there.
Yes, I
Hello,
am.
Maxwell, can you hear us?
Yes, I can. I'm here.
Okay, great. Yeah, so again, thank you for the great talk and intro that you've given us. I'm sure folks who are listening in are quite inspired. So I want you to share with us, like at a very high level, what your design process is. Like, how do you go from, when you have an idea to when you have the first prototype? What's your design process like?
Hmm. Okay. I'm gonna be very open. So basically, it all starts in our head, right from the net grade. We have an idea, we have a goal. So at Terra, what we do is that we build with purpose, because one of the ways you can keep things low cost, apart from low cost computing, is you you reduce how random things be or things are. And there is purpose behind every single feature, every single step. Yes, errors can be made, you understand? But the money we'll spend on randomizing how things are done, we can spend on the trial and errors. So first off, there is the idea, and then industrial designers come into play. You know, we open SolidWorks, we open Fusion 360, we design it. There's a CAD model for every single part, every single thing. That's even there are some screws that we even design on CAD itself before we even test out or buy. We design those screws on CAD and make sure it's compatible before we even start buying them. And then, we moved to seeing how, okay, yeah, there are machines that can achieve these things when we're talking about large scale production, but we can talk about the first prototype right now. So with that, how we get that prototype into play is that we hand make it. We basically make it manually. There are composite material that you can get off the shelf in the market that you can just easily use to form a new aircraft. You understand? You can even get polyethylene material and handcraft the aircraft. You understand, with a CNC machine or even with your hand. When I started, I was using my hand and I could get it accurately. The guys that get these things 99% accurate. And then we can test that idea. We can, fly it, see if it flies. So a lot of times it crashes. When we first started, we had more crashes than flights. When we first started, things were crashing more than they were flying. I think Calon was the only thing that only messed up once before it went, out into production. I think there was a time it became too hot, but it didn't fail. It was just too hot, for too long. And, systems were critical. Thank God for, processes that we put in place to identify those things that were able to bring it in. So yeah, car design, first prototype. There will now be a second prototype. That's now in that second prototype, we incorporate all of the lessons learned from the first prototype. And when you have that, yeah, you can move it to production, getting the first production model ready. Now, the first production model ready, there will still be mistakes. As a matter of fact, you will never ever see every single thing that you didn't get done until a customer uses it. Yeah, until it's in the hands of the customer has flown it, the customer has tested your security system before you even know there is any mistake. From the factory, as far as you're concerned, your system is working fine. The customer is the one that will tell you what works and what doesn't work. And then you bring it back to go through a final iteration process before you move it out again. So a lot of times I would advise engineers on here to learn with the people who are going to be using the product. Do not be the alpha and the omega, because I promise you, you are not the alpha nor the omega. Yeah. As a matter of fact, this is one of the industries where the customer is actually always right. Yeah. Most industries are not always right, but yeah, in this one, your customer is right, like mad. So you gotta learn with the customer, send it out to them, see what they think, and bring it back. You understand? Make those improvements, and then send it out back. As a matter of fact, it shows how genuine you are with your mission if your customer is the one that is building with you. It helps them grow with you. A lot of our customers have evolved into investors purely because of this particular, direction that we took. They're like, wow, I love the way you guys are building. Let me invest into the production process. Let me invest into this thing you guys. And then they would order. And they would order. And they will invest and then order more systems separately. So that's what you get for, building with your customer base. As you grow larger, this won't be the case. You understand? But this is for when you're starting out. So that's it.
Thanks so much. And by the way, we can't see your video in case I don't know if you turned it off. But thanks for that answer. And the other question I had is, and again, if you have any questions, please share them before we wrap up. The other question I had is, I'm sure something that is on many people's mind listening to you talk. For the people who work at Terra Haptics, right, who help you build these drones and so on, what are the
Yeah.
basic skills or knowledge that they need to have if I wanted to get a job as a robotics engineer, aeronautics engineer, whatever, at Terra Haptics? What are the, you know, not what, yeah, what are the things I need to know to be, one of your part of your team or a team like you?
So you don't need to know everything. You don't need to know everything. You need to know the basics. The basics are very important. For someone that working in the aircraft manufacturing section, you're going to be compiling a lot of sensors together. You need to understand soldering very well. You need to solder well. Your soldering will definitely get better when you join us, because Okoye will drill you. Your soldering will be better when you join us. But it just has to be good enough to actually get the job done initially. You need to know soldering. For anybody else to join the software team, that wants to join systems integrations, you need to understand mission planners, at least to an extent. From the basics, how to install a firmware on a drone, how to do initial setup, calibration, sensor calibration, how to check logs. You don't need to master reading logs, but can you be able to operate mission planner to a great extent? Because these are like the things that we use in prototyping. You might not even, there's a way you'll be, well, okay, you know what, you're good, but you're not like production good, you're research and development good. So we just put you on the R&D team. You understand? And there's some people that they are good, and then we put them in the production team. So okay, join final production. Where this guy will be working on all of the ideas I have in my head. You're the one that'll be helping me test it out and make sure it's good enough for production. And that is for the aircraft section, soldering, understanding the basic software tools that we use, get familiar with the sensors, the compass, the INS. INS is basically your accelerometer, your gyro, all of that stuff. So to join ground systems, the ground systems crew are the people who build things like the Kalon Sentry Tower and the Duma UGV. That place is tougher because you need to know things like welding, you need to, have, basic understanding of machinery, cutting tools. You will sand like mad. You will use angle grinders. There was a time I used an angle grinder so much I stopped feeling my own hands. You use an angle grinder for a long time. That place is you can learn things easier there because these machines are pretty much automated. You understand? So it does that you just work, they are heavy machinery, so you feel the heat more in that section the aircraft section has AC. That side doesn't have AC. so yeah, so you'll be working with tougher systems, but you don't have to know the entire world to be able to work at Terra. You just have to know enough. And when we bring you in, as a matter of fact, our systems, as we have a very tight culture that regardless of what you know, you still have to learn. You still have to go through a very thorough orientation process to know how things are done. Because we're not off the shelf. We actually have our own integration going on. So yeah. So just basic engineering skills, coupling skills, and a calm head. Yeah, you need to be calm to work at Terra. You're basically run. That's the word. Yeah, your head needs to reach ground to work at Terra. And you need to be calm, collected, because you will learn fast if you're more calm and collected. And just watch. Anything you don't know, just watch. Just watch someone else that knows how to do it. And you will learn it. You know. Because at the end of the day, the one thing you should be to work at Terra is smart. You need to be smart. If you're smart, the rest will follow. I said I know there are non-Christians here, but I pray a lot of times that I ask God for the wisdom to be able to assimilate things that I don't know, and help me streamline the knowledge that I have to fit what the company needs. Because a lot of times we evolve. A lot of times that requests will come up that you aren't even hired for, but we didn't hire a so engineer. We hired an engineer that would fit into different things. We pay well. You understand? For every evolution you'll be going through, you get paid for it. But those evolutions will happen. There's a lot of times you might need to go from fitting up aircraft to going into the aircraft mobilization team, where you're no more going to be in the factory. You're not going to be actively on the field demonstrating those aircrafts to customers, to clients, to investors. And even sometimes there are some people that are current, as I'm speaking now, there are people that are on the field testing aircraft we fitted last week. That is their job. They go out every day flying aircraft. While there are people that are in the company and the factory building those aircrafts for them. So that's it.
All right. Thanks for that. I'm sure some people, appreciated that response. The other question I had has to do with, you've talked a lot about hardware. Obviously,
Yeah.
that's the crux of this conversation. But in low-cost computing, there's also the software part of it, right?
Yeah.
And I know there may be some people who are either software folks or designers and so on who are listening, who will be watching the recording later on.
Yeah.
So how you've also mentioned that Terra software, like your software system is, I've heard you say it in a previous conversation, that that's the crown jewel of of what you
Yes.
guys have, right?
Yeah.
So can you talk to us a little bit about, for somebody who is in the software space, who is trying to interface with the hardware folks, right? How are you able to make this work at Terra, or how can somebody who is in the software space trying to work with folks in hardware, what are the key things they need to know, and how do you make that work?
Hmm. So there's basic language understanding is to know, okay, what languages play a huge role in this industry. When I first started, we were very Python and Go focused, because that was a low-hanging fruit. I've been a Python developer for years now. I also have my C++ knowledge hanging around there. And we had people on the team at that time when I first started the company that, we are very good Go guys. They had Go knowledge. Today we use Rust. We use Rust. That's what we use today. We use Rust. There's a little bit of Java in there and TypeScript for the front end. I'm just letting everybody know the kind of languages that we use. So you know that, okay, yeah, I have the knowledge. I have the knowledge, or I don't have the knowledge. So those are the languages we were using when we first started, and we're currently using Rust right now. And they are also the good thing about the hardware side of things is that there's already established software you can actually use for your programming. But to take the automation, the intelligence, things like even obstacle detection off your hardware to the next level, you need to understand the software part. For the Arduino IDE, we use C++ there. It's basically like a C++ derivative for the Arduino IDE. So those are the languages you need to understand. You understand? And to be able to, get to the software part. Yeah, they are open source software tools that enable plug and play. But if you want to do things more bespoke, more custom, yeah, you need to know these languages to certain depth.
Okay, thank you. And last question before after this question, I'll share more about the challenge. And if there are any questions from the audience, we can answer that. But if not, then we
Mm.
can close. So, we're in a world of AI, everybody's talking about AI, right? Have you seen or are you seeing any applications of, like in everything you talked about, like monitoring, low cost computing in the factory and so on? There are people who are saying that because of or let me frame it this way. Have you seen or are you seeing any places where AI can be applied in low cost computing for manufacturing? Is this something you're coming? I know everybody's talking about it in theory, but
Yeah,
like in practice, from what you've seen, are you seeing that come up in your work?
a lot of times, a lot of times. Okay, let me even give an example now. 3 days ago, a customer called and was like, "Oh, we're enjoying your systems. We love it." They're an energy company, and they were like, "But we have a problem. We need to automatically detect when there is rust or corrosion in our power stations and our transformers, and we need to know when a power line is defected. We also need to know when there's thermal based anomalies too in our systems, when one place is hotter than the other." And we're like, "Okay, we can get that done for you. We have that in the back." Terra Haptics has one of the largest, and I don't think any African company has the data sets when it comes to critical infrastructure like we do. We have one of the largest data sets in Africa when it comes to critical infrastructure, when it comes to rust and corrosion detection, when it comes to line defect detection, when it comes to understanding mineral veins, when it comes to understanding when there is an anomaly in a pipeline, bridge cracks. We have data sets. We literally have our own AI model called Taskmaster that actually analyzes that data and then feeds it to us in the front end. And yeah, AI is here. AI is here and it's here to stay. It's very, very essential because AI and automation go hand in hand. If not, you have to be programming a lot of these processes yourself. Your machine has to learn. Your machine has to be actually intelligent. And people forget that AI is just basically machine intelligence, artificial intelligence. You're just making your machine more intelligent than it would have been if you gave it a manual command. I know America, Japan, China, their own AI don't cross, certain levels. But here we can, we have the opportunity with the tools available to us to actually build intelligent systems. And when I mean intelligent systems, basically, a system that can help you carry out certain processes with minimal input from your own end, minimal input from the customer's end, and feed you that data and help you do something with that data. So yes, we are building the AI for these critical industries. So yes, it's very, very practical. And we are seeing it even used in, manufacturing processes as well. So yeah, for right now, we've basically automated our entire firmware integration to integrate firmware into every single flight controller before we ship it to the next line in production. So yes, AI is very practical. AI is here. Yeah.
Okay. Thank you for that. We have a question from the audience from Lothar Phillips.
Philip.
He's asking, will the Terra training be for only Abuja residents?
My brother, Luther, how do I say this in a way that won't hurt your feelings? Yes. Because you can't do manufacturing remotely. I mean, check El Segundo, check SF San Francisco. All of the guys, when they hire anybody from anywhere in the world, they bring them down to El Segundo. You understand? Because you got to be hands-on. You got to get your hands dirty. So all our guys live in Abuja. As a matter of fact, there's some of our guys that live in that they come from other states. These are the guys that these ones are not interns. They don't be trainees. They be actual manufacturing experts that we brought from Kaduna, Mina, from there's one from Akure, there's one from Lagos. I know many of them are from Kaduna. We brought them and we gave them a place to live, quite literally, because they had to be, in person. Some of them are currently living in my house right now. So you understand? We're having a meeting at my house, and they literally came all the way from Kaduna here because we have like 100 and something towers to produce. And so they are here. So yes, even the software team, our software team is in-house. I'm flying in the entire software team that is remote in. I'm flying them in next week for a meeting for a new feature, because there are some things that they won't understand until they've seen the hardware in person, tested it, played around with it before they can even understand what they're even trying to achieve here. So a lot of times, not a lot of times, all the time, they have to be in person. So I'm very sorry, Lothar. Yeah. I wish there was another way, but there is none. Yeah.
So, but maybe one day, as there'll be a Terra Haptics campus in every
So
country.
one day. No, it's something that okay, I haven't talked about this anywhere else, but one of the things we are doing, especially in another Igbo, let me call it an eastern state. We are planning for the next set of factories that are going to be opening for the next set of factories, not just with them within Abuja, but also, in the east, west, north, south, because we actually want factories in every single geographical location, in every single cardinal point, and also beyond just, Africa, also beyond just Nigeria. There's going to be campuses. So very soon, Lothar, you'll be able to come to Abuja. That is if we deploy you to Abuja, because there's a high chance we'll just deploy you to another state. But if we deploy you to Abuja, you're going to be living on campus, on the Terra campus. So that's it.
Okay. Thanks so much. So please stick around, Maxwell, while I just share some more information about the challenge for those who are hearing about it for the first time. And as I'm sharing, if you still have any question for Maxwell, any question about this and AMA session, please use the Q&A section for that. So again, this is part of the Africa Deep Tech Challenge, and what we're trying to do here is to encourage folks to build awesome stuff in the area of low resource computing, which is basically computers that are constrained in terms of the resources they have, whether it's CPU power, energy or power supply, access to the network, memory, so very constrained computing, which is typically what we have access to in the region. So we're looking for people who can innovate around that in any space, right? Whether it's hardware, software, AI, extended reality, Web3, and so on. Actually, that reminds me, I have a Web3 question for you, Maxwell. So gear up. But we're looking for people who will innovate in any aspect there. And our goal is to find these people through this challenge so that we can continue to support and promote you, right? And by taking part in the challenge, again, I'm going to pop the link in the chat, right? Or maybe I'll even just I'll share my screen real quick. Hopefully you can all see my screen. By taking part in the challenge, you stand to win a bunch of prizes. We're not doing it alone. We're working with a bunch of partners from the Co-Creation Hub, the IHS, which is one of the top telco infrastructure providers in the region, the Learning Innovation Hub, Future Africa, which is one of the top VCs in the region. We have community partners like the 3MTT program, the ARM Distinguished Ambassadors, CALA, ISN Hubs, the AR/VR Africa community, GDG Lagos, and the Omniverse. And of course, we have Web3 Africa as well as one of our partners. Really, like I said, what we're expecting you to do or asking you to do is to innovate around resource-constrained computing. Whether it's building AI models on edge devices, offline first systems, decentralized computing, energy efficient technology for manufacturing or whatever it is, just do it. Like Maxwell said, whatever, whatever you want to do, do it first. So just do it and let's see what you have, right? Whether it's in agriculture, education, health, manufacturing, or gaming, whatever it is, so long as it's resource constrained compute. And what we're asking you to do is to have a working prototype that you can submit. And you submit that working prototype and a comprehensive project report that talks about what your problem is, what the constraints you're working around is, all the design decisions you took, the tools you used, performance tests, and include screenshots and short videos as needed. And also, we want to see a pitch video, a 2-minute pitch video explaining your solution, because that's what the judges are going to look at before they even read your project report. And if you get chosen for the semifinals or finals, you'll be asked to provide updated information as well. For the prizes, I'll just start from the bottom, right? So if you make it, when you submit, you make it to the semifinals, right? You get a recognition certificate. And basically, one thing I'll say, regardless of who you are, right? Taking part in this challenge, you're going to gain something, right? So, for example, you're already here part of this session. You've heard from Maxwell. We had a session before from IHS Towers talking about power solutions as well. We're going to have even more sessions coming up. So, you're going to get a knowledge upgrade just by taking part in this challenge, right? If you make it to the semifinals, you get a recognition certificate and you're going to have access to mentors, right? That we're going to provide. So we're going to get top people in the space of your project who commit to spending at least 1 hour with you to help you upgrade your idea and, get you ready for the finals if you make it that far. If you make it to the finals, you're going to be part of the live demo opportunity in front of basically the whole world, right? Where you demo your solution and get questions from the judges, which is great exposure for you. And you get even more mentorship as part of that. You get professional documentation support, and you get access to our partner network just for being a finalist. Now, of course, we have prizes, right? The first one I'll talk about is the IHS Challenge Prize. So IHS is in the telecommunication infrastructure space, and they put up $4,000 for anybody who can create a wow solution in the power management category, regardless of whether you win the contest or not. Right? You stand a chance to win $4,000 in cash from IHS if you create an awesome solution in power management. If you get a third place, you're gonna get, and of course, if IHS gives you that prize, then it means that they're gonna be very interested in your solution. So that's already one thing to think about. There's a $3,000 prize, right, for the third place. And that comes with other things like mentoring and access to our network and so on. And there's a $5,000 prize for the second place, which also comes with all the good things we talked about. And for the first place prize, you're going to get $8,000 equity free grant. And, you know, regardless of which one you fall into, so long as you have a great solution, in addition to the cash prizes, we are going to promote the hell out of you. That's the promise we're giving to all people who submit quality stuff to this challenge. Right. So again, I just wanted to share that for folks who are watching this or joining for the first time, just so that they understand what this is all about. And with that, if there's no other questions from anyone, we would like to thank Maxwell for joining us and for helping inspire us with this conversation around low resource computing in manufacturing. And we would like to thank you for attending. And please, if you have more questions after this, something you forgot to ask or something you want to think about, be sure to reach out in the Telegram channel. We'll put the link in the chat with your questions. Join the Telegram channel and we'd love to hear from you. We're going to share details about Maxwell's training program in the Telegram channel as well for those who are interested or for those who want to have access to them. Thank you. And Maxwell, if you have any last words for our audience, both live and people who will be watching the recording.
For those who are on the Telegram group, you don't need to apply via the link. Just send me an email directly saying that you're from. Don't go and tell people outside. Just the people on the group. Just tell them that just on the email to my personal email, Maxwell Terra, just say that, okay, I am from African Deep Tech Community, attended your webinar. These are my skills. This is my CV. And shaking up. That's all you need. Then I'll take it from there. If you still want to apply via the form, you are feeling official, no problem. But that's all you need if you attended this webinar. So yeah.
You heard it here first. Okay, thank you, Maxwell.
Yeah, also I'll be giving out, for those who are really interested in hardware stuff, I'll be giving out 3 Arduino kits. Yeah, I'll be giving out 3 Arduino kits and a Raspberry Pi set. So I'll sync with either Fumi or Ogameka for that one to go around. Yeah.
Amazing. So you heard it here first, folks. These are the benefits of taking part in this challenge. Even before you submit, you already have the opportunity to win amazing stuff. So really grateful to Maxwell for that. And we'll coordinate on the Telegram channel to talk about how we're going to make this happen. So again, thank you everyone for attending. Thank you, Fumi, who has been behind the scenes, making sure everything works. I really appreciate you. And yeah, thanks everyone. And we'll see you on the next one. Thank you. Bye-bye.